Welcome everyone to the KMC Controls webinar on Control Basic Line Code Programming. Happy July. We're so excited that you're here joining us for this webinar, and we're really excited to bring you this content. Today we're going to be having Eric Kruder, Kevin Mooney, and Gene Stutzman, our Building Geniuses team here, going over some line code programming in Control Basic. So we're really excited to have all of them with us today. Questions during the webinar, feel free to go ahead and type those in, and we'll try to attend to them if there is time, but we also use these to guide our future webinars, or we'll answer any questions offline if they're necessitated for that. So I want to launch one quick poll just before we get started on how familiar are you with line code programming? So let me go ahead and launch that real quick. We appreciate that very much. All right, so without too much further ado, we're going to be moving into a live demo where we're going to go and start looking at all of that. So let me go ahead and hand things over here.
Well, good morning, everybody. This is Eric Kruder, and like Andrew introduced us, we've got Kevin and Gene here as well. As we start to share our screen here, we first just want to talk a little bit about how Control Basic operates, so that it kind of everybody gets in the same page of where we write code and what order we write it in. And then after we talk about that, we're going to show you a couple line code examples and a little bit about what goes into a basic Control Basic program. For any advanced topics or anything specific we see in the comments, we will schedule that in another webinar and take a little bit deeper dive. So with that, we'll let's dive into the software.
So you're showing me. Yep.
Screen. Yep. Okay, so here we're looking at a screen of Connect, and over here in the Network Manager, we've navigated through the tree and we've found a Conquest VAV controller. And then inside that Conquest VAV controller, we have several programs here. The default panel file uses 6 programs. The first one being set points and modes, and the last one is the icon and display. So a little bit about how Control Basic works. The Control Basic, or the controller, is going to scan the or run a scan, and we got a little picture about how that works here for everybody to look at. So at the start of a scan, any point references in any of the programs are going to be read by the controller. So that would include inputs, outputs, loops, variables, again, any point or reference that's made inside that program. And then program 1 is going to start to execute. So for us, that's going to be this set points and modes. We're determining if we're going to be in heating or cooling. We're going to be determining, maybe set point limits and things like that, setting ourselves up for more of the control functions in subsequent programs. But as this program runs, anytime that we have a, we're starting or stopping a variable, we're going to update that variable in real time. So that way we can use it in the same program or in subsequent programs. If we're starting and stopping an output, we're going to hold that value until the end of the scan before it's updated. And we'll talk about why that's important here in a second. So program 1's going to run. As soon as we make it all the way through program 1 to its end statement, then we're going to go to program 2 and the process starts again. So here for at VAV, it's going to be damper and fan operation. We're going to run all the way through that program, updating variables as we go, and then jump to the next program in the line. And this happens for each program until we get to the last program that has any code in it. So for us, in this Conquest VAV, that's program 6. At the end of the scan, then we update all the outputs and the scan starts over. The thing to remember here about holding the outputs to the end, that's especially important if we want to add any safeties. We would recommend safeties be in the last active program. Best practice would be to put them at program 10, so we make sure that the all the safeties get run last. The reason we put them there is that if I update an output here in program 1 or 2, say I have some condition I haven't coded correctly, and maybe I have two outputs on at the same time. It could be clockwise, counterclockwise for an actuator that I'm allowing on at the same time, or it could be heating and cooling, you know, or anything that I wouldn't want to be staged together. I can put that in the safety program to say, hey, if output 1 is on and output 2 is on, then turn them both off, or just start output 1 and leave output 2 off. It putting that safety code in the last program, you know, protects me a little bit from doing something that maybe I didn't expect in the earlier programs. So this whole process of a scan runs several times per second. As you put in more code or more complicated code with some of the more advanced keywords, maybe dew point or enthalpy, things that take a lot of calculating, or if we use a lot of wait statements, we'll see that scan rate start to go down. So again, be cognizant of that if you're trying to do something really quick. You know, we're going to want to watch that scan rate as we really load up the controller. So let's go back to the to connect here, and we'll talk through what is in each of these slots. So we have set points and modes. So again, things like determining if we're going to run in heating or cooling, you know, what set points are active or what their limits are going to be in that program 1. Here, since we do have a few different programs for a VAV, we've split damper and fan from reheat just to make the code a little more easy to understand and dive into versus trying to have everything in one big program. So functions that are similar, we can put them in unique programs here. And then we go through damper calibration and balancing, 2 things that are VAV specific. And then a last program, just icons and things that are going to go on that net sensor to have more of a user interface display. There's 4 empty programs here in this panel file. So if we're going to do custom programming, maybe things like pick up an exhaust fan or point passing, we're going to say, you know, put that custom programming in program 7, 8, 9, 10. And again, group similar functions. So that exhaust fan logic may go in program 7, and then any point passing or off panel points, you know, put those all together in program 8. The better you group your code, the easier it'll be to debug in the future. So with that, we'll, the last thing I want to talk about is kind of some best practices about how we organize our code inside of the program. And we're just going to look here at the damper and fan program and talk a little bit about what we see. This is a fairly long program. You know, it's going to be 70 lines. A lot of this is comments. Comments are good because it can tell you who wrote it. Here we see that Gene wrote this program. The last version was 2017, and we put a version number in here. So that way, you know, if we come back to this program, you know, a year down the road or a couple years down the road, we can kind of gauge, you know, the age of the program or if there's been any updates to it. We like to put notes here if we're using any locals or labels. Again, just so another technician coming into this is going to have a little easier time navigating through it and understand what we're doing. So the first line of code we see here is going to be that main program loop. We're a big fan of Go subs, or what we call subroutines. Again, grouping similar code inside of subroutines makes your code easier for other people to understand. The way this is going to operate is we're going to go to this Go sub statement, come down and come back, and then we're going to run this subroutine and then this subroutine and continue on that until we get to this end statement. As soon as we hit the end statement, then this program is complete, and we're going to go on to, in our case, program 3. So inside this Go sub here, we're doing calculating airflow set point and taking an airflow reading and then returning. The nice thing about that is if I have questions on how that's calculated, I'm going to open up this damper program. I'm going to kind of pick out the area that I want to look at, and I'm going to go right to it. I'm not necessarily having to read all the way through the program and decipher what some of this is going to do before I get to the piece of code that I want. So good use of subroutines, make sure everything's commented, and the better description you can put here, the better. All of this is saved inside the controller, so it's on the job, ready to go when that next tech comes by, or if you need a good reminder of what you did yourself, a couple years ago when you wrote this. So with that, we're going to have Kevin and Jean come down here to one of the empty program slots and show us how to write a basic custom program using line code inside this VAV controller.
Thank you, Eric. This is Kevin Mooney. I work with the applications and with tech support quite regularly. I think Eric did a good job of sharing with us what's going on here. I would make couple of additional comments. Sorry. A couple of additional comments. This code can be changed in the field. It's not locked. If you're going to change this code, make sure and comment where you change it, so that if it doesn't work and you need help, one of us to look at it, we know what was the original and what you changed. Other way of doing it is writing it in a custom program. That would be the way I would prefer you do it. And then write over top, don't change our code, write in a custom program and write over top or command at a higher priority the variable or output. That way our code can run underneath yours, and you can see that our code is running, but you can also see your code running. Okay, anything to add, Gene?
Not that I can think of.
Okay, what I'm going to do now is I'm kind of the software guy, so I'm just going to run you around the software a little bit so you understand what all the buttons do before we actually start coding. A program object, this we call, they're object oriented, so this is a program object, each one of these. Make sure you label that program when you start doing some code writing. I've seen whole controllers with no labels, and so I don't know what's inside that. So to label it, actually, you have to come up here to these general properties chevron, expand it, and right here's where you add the name. There's a couple other things I want to talk about while we're here. This run on cold start means that the program will run every time there's a power cycle or you purposely cold start it. So we're going to make sure that's always checked, because if that's not checked, as soon as you restart the controller or the controller loses power, it won't run the program anymore. This is showing that the program state is running. These are all BACnet terms. You can command it to do other things. You can command it to restart or unload or stop it or halt it. Halt is kind of a special function. The program can become halted on its own if you were to go in here and delete one of these objects, like this B01 that's being referenced. If you were to go to the controller and delete B01, this program would halt. And it would show you in here that it can't find B01. So it gives you a description of why it's halted. And sometimes accidentally we create race conditions where we're just spinning in a loop inside here. And after a while of doing that, this program will halt and it'll tell you that it's in a race condition. Okay, that happens sometimes. So that's probably enough here, giving you some background, what's going on in these general properties. Inside the editor itself, the first time, let me open up a blank one. So the first time you look at one of these, the very first time you try to ever do any programming, you're going to open this screen up and you're going to stare at this blank program and probably think, what do I do first? We've all been there. Typically, when I do a lot of the training, I tell people to just start typing and type an if. And then think about the condition. What are you trying to turn on and what are you trying to turn off? So almost always your line starts with if. So you can ask that question. But that's my recommendation when you first start, the very first time you ever start typing, gives your mind an avenue to start thinking. So let's look at the screen a little bit closer. When we actually type in here, we have to compile to make sure our syntax, what we typed, the controller understands what it's trying to do. If there's errors in the syntax, meaning you need a space there, you need a comment, you need a parenthesis, you need something, or the controller doesn't understand what happened, it'll show up in our output window that there was an error, and it'll give you a line number to try to figure out where it is. The output window's down here usually. So when you compile a program, that does not necessarily mean it's saved anywhere. So if you were to close this editor after only compiling, you could lose your program. Okay, so you can save it off as a file, or you can put it in the controller from here once it's typed. If you actually say run, the little play button there, it will compile it, save it down to the controller, and run it. Okay, then you'll get your syntax error that says, oh, I tried to do the compile and I found a problem, so it won't save it to the controller and try to run it. So save often, compile often, and run often. That's just one of those, it's like using a Word document. You got to make sure you save it, run it, because you don't want to get way into it and then have a whole bunch of errors and have to keep going back to other programs and trying to figure out where my errors are. So compile and run often. Halt just means halting the program. Unloading it means it takes it out of the memory of the controller. It stays in the file. Clear, they've added a little prompt here, but you can clear the program. Sometimes guys say, well, I don't want any of this programming from the factory. So you just hit clear and it'll wipe it out. And you can start over doing whatever you want. But it will wipe it out and it's gone. You have to go to the resource manager to. So block editor, we do allow a block editor. So one of these, this button right here opens up the block editor. So you could use blocks instead of line code. We do have live values so that you can see if you put a binary variable or any one of the other variables in here, what its present value is. It'll start showing you. I think that's really all I wanted to talk about here. Oh, one other ditty. This is a help button up here. Sometimes guys miss this little question mark. You can also find it over here under help. It's on the other screen. Let me drag it over there. So in the ControlBasic, there's keywords. These are all the keywords that we use. These you will find, you'll have to look at each one of them. Maybe you're looking for a particular function. Something as simple if then. You can see that we have a couple of different editors there. The standard BACnet is, every one of our BACnet devices supports this. The next generation has some variations, which Conquest uses next generation, but it also uses standard. So you could use either one of these formats. The KMD is our proprietary line, and it's a little bit different. Sometimes it calls things different. So it shows you examples though of each type of compiler. Just know that Conquest can use either one of these standard BACnet or next gen functions, but you couldn't type it in like this, the KMD examples. But for each one of these keywords, there's examples like this. This is very, very handy. This will become more of your friend if you can't remember the keywords, what you're trying to do. All right, I just wanted to quickly show you that. I'm going to close this. Now, the next thing we're going to do is we're going to actually get into typing. So I know that's what you all came here for. I'm going to let Gene type, but I think I'm just going to give you a flyover. We're going to talk about some very, very basic things and how to do them. And he's going to just type out some fan sequences, like how do we start a fan and how do we stop a fan. So I'm going to turn it over to Gene now. So here's Gene.
Okay, thank you, Kevin. You did a very good job. So let's start writing a little bit of code, since that's what we were all here for. One of the suggestions that you've heard Kevin and Eric talk about was making remarks. So we always want to make remarks, and I'm just going to remark that this program starts and stops the fan. Okay. And we can put down that Gene wrote this. And the date. And today's date is 7/19. Okay. So there's just some simple things at the top of the program that you can put for information. So if somebody else goes into this program, they know that Gene wrote it, and they can they know his phone number. They can call him and ask some questions. Okay, so let's start and stop a fan. So we're going to use a if-then statement.
And you're going to use mnemonics, right?
And I am going to use mnemonics. We can use labels also. Advantages to using mnemonics is that we know where that point is located when we're looking at it in the ControlBasic. The disadvantage, you don't know what the mnemonic is necessarily doing. You're going to have that in your head. If it was a label, you knew exactly right away what it was doing. So we're going to use B5. BV5 is our occupied status. Okay, so if we're occupied, then we're going to start BO1, which is the fan. And what I can do to help me is put another rem statement in if we want, just to say that BV5 equals OCC and BO1 equals fan.
So one other thing to remember when you're deciding if you want to use mnemonics or labels, it is personal preference. As Gene said, there are pros and cons to both. Generally, if we use mnemonics, like Gene said, to refer back to that point easily in the list, and it makes the text of the program a little shorter. So we would rather put in more comments to tell what we're doing than to write out that label in the actual code. The other thing to consider is if we're going to take this program and move it to another controller, reuse it, we're going to want to make sure that whether we use mnemonics or labels, that everything matches in that new controller. If you're going to compile with labels, the mnemonic associated with that label is resolved at compile time. So if we just move the program over to a new controller, you're going to have to recompile to pick up the new variable references, even when you use the labels. If we use mnemonics, it's a little easier to move from controller to controller without having to worry about that recompile as much. So that's why we choose to use mnemonics in a lot of our programming here at KMC.
Okay, as you see that I typed in end, you see this little screen pop up, which makes suggestions for keywords while you're typing. So you can find these, like if I wanted end if, I could just click on the end if and it would put that in there for me. Okay?
You can turn it off.
So, okay, so now I've written a simple program here that says if BV5, and we assume that BV5 is a value of 1 if we don't specify. So if BV5, then we start BO1. Okay, so now we also got to remember, now that we've started BO1, somewhere we're going to have to stop it. So always remember that you have to stop whatever you start. So in the second line, in line number 7, I have written, so if not BV5, then stop BO1. Now, there's a couple different ways of writing that exactly same thing. We can also say if BV5 equals 1, then BO1 equals 1. This line does exactly the same thing as line 6. And we can also rewrite line 7 to say if BV5 equals 0, then BO1 equals 0. Okay, so now line number 7 and line number 10 say the exact same thing. And there's another way of doing this. In one line, we can say if BV5 equals 1, then BO1 equals 1, else BO1 equals 0. So now we've done in one line, line number 12 does the same thing as line 9 and 10 do, and also the same thing as line 6 and 7. And there's one more way we can do that. We could say BO1 equals BV5. That also does the same thing. As you can see, line 14 takes the least amount of characters to do the exact same thing. But it's really not a conditional statement. It just equals to BV5. Now, if we want to do some other things like look at another point to decide whether or not we want to start that fan. Let's say that we want to look at like a door switch or something. So we add a door switch. Let me come back here. BB10 will be our door switch. So now in number 6, we can say if BV5 and BV10, then start BO1. So in this line, both BV5 and BV10 have to be a value of 1 in order for the fan to start. Okay? And we also want to add that into line number 7 to say if BV5 10, we want to add BB10 into this conditional statement. So we have to use the word and BB10 equals, or no, we want the or statement. I apologize. We want the or statement here. Or not. Got a little ahead of myself. There we go. Now, let's compile these, what I've done here, and we're going to see something happening down there at the output window. And that has all compiled for us. Now, do we want to see what happens when we don't compile? If I add BV10 or BV110, which does not exist in this controller. Oh, it does exist. It does not exist. It did compile for me, but we'll show you what happened to the program. In the general properties, we will see that the program actually didn't run. If we give it a minute.
So we had one question submitted about adding time on or time off, maybe for compressor runtime, where Gene had written the and BV10 or BV10, we could add a condition in there that was, if BV5 and BV10 or time on BV10 was greater than so many seconds, then perform whatever is in the then statement. So as Gene's showing you here, if we want to add other conditions, we're just adding them to that expression that we're typing inside that if statement.
So that tells us if the occupied or BV5, if that time, once that time is on for 5 seconds, then it's going to start BO1, which will start our fan.
So we can express that number in seconds, or if we wanted to express it as a function of time, so say maybe 5 minutes, we can write, instead of writing 300 seconds, we could write it out as the expression of times with colons there. So either would be valid.
Okay, what do we want to show them next?
One thing that we do a lot of times when we're adding code, we should comment each of these sections, but let's just go ahead and we want to try to run this program. So let's make it compile, take our reference to BV10 out. Gene's clicking faster than I can talk. And we'll show you what these live values would look like in the controller. So Gene's clicked run, that compiled the program, it pushed it down into the controller, and it's running that program, and then opening up the live values, we're seeing that for any variable that we're referencing, we're gonna pull out that current value. If something were to change in the controller, our schedule tripped and our occupancy point had changed, we would see unoccupied there in that live value window.
Okay. We could do that.
So I think the last part of this example, since we've gone over just basic setting of variables, referencing variables, even though the functions are a few different ways, let's show you an example of how we would build out, a few different subroutines and structure our code there. So we're going to add a go sub loop at the top and an end statement at the top, and then we're going to put a label around each of those code sections that Gene wrote. Again, this is going to be a little bit different because all the code does do the same thing, but I think you'll get the idea of how we would structure those go subs in some of those larger programs that we do, right? So as Gene types this out here, we'll give him a minute and Then we'll talk a little bit about what he's doing here in a second. The biggest thing with go subs to remember is that whenever you have a go sub, you're going to want to put a return in. That return keyword signifies to the compiler that that section of that subroutine is over, and we need to jump back to wherever you entered the go sub.
Got it. And you also always have to remember when you make a label, you always have to have an underscore.
No spaces.
Copy.
You don't have to have an underscore, you just can't leave spaces.
Oh, yeah, that's.
Sorry.
So in this case, if you pause there a second, Gene, if we were just to leave our code like this, we would run the first go sub, jump down to the first set from lines 9 to 12. We would then return to the where we entered the go sub there at line 6 and go sub into 7 into that second set and come back to program our line 14 to 17. If we didn't put an end statement after line 7, then we're going to continue reading back down to lines 9 through 11, and we're going to probably go off in the weeds. So if you're going to do these go sub loops, we need to make sure there's an end statement after that last go sub there, or you're going to run into your previously written code. So now we'll let Gene keep typing. So we want to make sure we put an end statement there. We'll leave the last couple lines there that we would have had for the third set. We can either put that reference in or we can just run it like this. Without putting that third go sub in, this program would actually never get to lines 20 or 22. It would run 10 through 13 and then 15 through 18, and then the program would end
Back here,
never hitting that 20. So if we wanted to run something on lines 20 or 22, we'd want to put a condition in to jump down to those lines. So
you want to delete this and compile it and show them an error?
Okay.
No. Okay, let's start either one, either keyword.
We're going to show you what happens when it does not compile. So
go ahead and clear your output window there, Gene. Just a right click inside that window. That way we know we're going to get the messages for the current operation. So here we have we've removed that then reference, so the if statement is not formed correctly. So that compiler is going to chunk out a bunch of errors and say that hey, something's not valid, and it'll give us a clue as to what's wrong. So there's lots of references to line number 11, so that's where we want to look first, and then it'll give you a clue to either it couldn't find a keyword it was expecting, like then, or a variable wasn't referenced the right way, or a variable was referenced out of order. So it happens removing that then statement, there's a few different errors in forming that line of code. So
okay.
The last thing I think that we're going to touch on today for this just basics of line programming webinar is when we want to have, or when we can use commas and colons. And we're going to use this here in that first line. Maybe Kevin can talk a little bit about what a comma is and what a colon is.
Well, you can see that Gene has created another command on the same if statement, if then. He's starting BO1. You have to tell it each time after a comma what command, either start, stop, on, off. So after the comma, then you start BO, you have to tell it start BO2. You can't just put BO2 in there.
Right.
Then if you want to make a comment at the end of that line, you need a colon, because a colon indicates that this is a new line. And you can simply write then the REM statement, the REM, and there has to be a space after REM. You can't start typing this unless there's a space there, which you see Gene doing. So it's the REM and then a space. That's all part of the REM statement. The code, the compiler or the controller will not execute anything starting with a REM. So it stops executing that line when it sees REM, and it goes to the next line.
So just to make sure I understand what Kevin explained, a comma would be used if I want to string multiple commands together on the same line based on the same conditional statement, that same if. A colon is a way that we can have two independent lines of code or snippets of code written on the same numbered line. So we only do this, we only use a colon when we want to shrink how many lines of code we're doing. So if you see a colon, it's exactly the same as, you know, having something on line 11 and something on line 10 versus just written on line number 11.
Yeah, a lot of times I've seen guys just like say something equals something and then a colon, and then BO2 equals BO3, then a colon, BO4 equals BO3 and a colon. So they can just stack up a bunch of what would normally be lines in a list, lines left to right.
You know, starting a fan and starting a first heating stage, or the fan and a first cooling stage, something like that.
Mm-hmm.
Yeah. And then since we have a minute or two left, let's just touch on the order of operations. Maybe we can do an example just with math, and then we'll do an example with adding that to an if statement. So let's go down. We'll just make another line in between the second set and end. And here we just want to run a calculation. So let's just write something that would use a parenthesis and addition and multiplication. So and we want to say AV1, we're just going to make up a reference here. AV1 equals parenthesis AV4 times AV5, and then we'll close that parenthesis, plus AV6. So here, just like you would normally expect, we're going to run the parentheses first, then we're going to run multiplication, division, and lastly addition and subtraction, just as you would expect. If we didn't have the parentheses, or we wanted to move the parentheses around AV5 and 6, we would add AV5 and 6 before we perform the multiplication. So when we're dealing with math, it's just as we would expect with basic order of operations, pretty easy to understand. One thing we see when you start applying parentheses to the conditional statements, you know, generally we don't think of running an and before an or, but it can significantly change how we how that statement is run. So let's jump down to that first conditional statement here, and let's run. We're going to add an or. We'll say or BV3. I'm not sure what BV3 is, but it doesn't really matter. Here we would want to make sure that you know, we think through that logic, because I have an and statement as in the statement before. So if either BV5 or BV10 is a 0 or off, then we're going to ignore the last part of that expression, or BV4. So depending on what we want to act, we might have to add some parentheses around one of those operations.
So we could maybe do this.
So let's add a parenthesis around BV10 or BV3. BV10 is a door switch. Maybe BV3 is a window switch. So here we're saying if I'm occupied and either of my switches is active, then start my fan and my valve. We could change how that logic works depending on where those parentheses are, and parentheses become more and more important the more conditions I want to put into that expression. So be mindful of where you use parentheses and kind of the order of operations when dealing with math. So with that, I think we're about out of time. We'll pass it back to Andrew, but again, submit any of your questions. Maybe you have a more advanced topic you want us to go over, and we can pick it up on a subsequent webinar where we've got more time to dive into something a little deeper.
Absolutely. Thank you so much, guys. That was really great. I'm going to take back over here. Perfect. So before we end the webinar today, I just wanted to remind everyone that we have started creating a ControlBasic series on our YouTube channel. And so we go through in series the theory and concepts that we kind of talked about at the beginning of this webinar. And then we also move into some of the examples and demonstrations. And we're going to continue to be adding to that series. So that's a great resource. And this webinar will also be on YouTube, but you can also find all of our content on our brand new website. It's still kmccontrols.com, and we have a new series of videos on that as well, detailing all the new features of our new site. So definitely be checking that out. A lot of updates and things have changed there. And again, all of our webinars are on YouTube, so you will get a link later today, so you can always rewatch what you saw here and reference it for later. And of course, you can follow us on any of our social media, LinkedIn, Twitter, Facebook, YouTube, and our Instagram channels, where we continue to publish all kinds of great content to be the intuitive and responsive, supportive people that you know us to be here at KMC. And we just want to thank you again from the Building Geniuses for attending our webinar, and we hope you have a great day and have a wonderful end of your July.